Is there free energy hiding in your spare change? In this video, you'll learn how to turn a handful of pennies into batteries that can power some of your small electronic devices. For this project, I'll need pennies. My neighbor Trevor gave me these, and I'll begin sorting them by date. I want pennies newer than 1982 because they're nearly 98% zinc. Okay, I've picked out 10 pennies that I think will work, so I'll use this 100 grit sandpaper and start sanding one side of the penny. Actually, this may be too much work, so I'll try some double-sided sticky tape and an orbital sander. This is working much better to expose the zinc, but the adhesive has melted from the friction and left these pennies in a sticky mess. No problem, I'll just use some adhesive remover to clean them up, and now they're looking great. It's time to build a battery. I'll cut some thin cardboard into pieces just bigger than the penny and throw them in some vinegar. While those are soaking, I'll start my battery cell by placing one of the pennies with the copper side down on a piece of aluminum foil. As you can see, nothing is happening yet, so I'll blot dry one of my cardboard pieces and place it on top. This time when I measure the voltage, I'm excited to see over half a volt from this one cell. I'll add another penny and cardboard and repeat the process until I've stacked up all my pennies. Now the cells are connected in series and the electric potential has jumped to nearly 6 volts. Wow. This should be more than enough voltage to drive an LED, so I'll test it out with this one. It works perfectly, and I can't believe how brilliantly this lights up. Just for fun, I'm testing the current draw and it's pulling about 170 microamps. I can even light up 2 at once. Okay, so it works, and it's actually really impressive that I'm getting electricity from pennies, but now I'm curious to know how long this can last. I'll use some electrical tape to hold everything in place, and try to fix these cardboard edges because they shouldn't be touching. I'll do my best to make it airtight to prevent the wet cardboard from drying out too quickly, and then carry it with me for the next couple of hours to watch for when it dies out. Okay, so now it's more than 2 days later, and I really can't believe what I'm seeing. The green light is still on, which means these little pennies are still pumping out juice. This is awesome, so I want to try another idea. I've picked up a calculator from the dollar store, and I'll remove the screws on the back so I can get to the battery. Once that's removed, I'll pull the negative and positive leads out of the casing, and now I'll need to make another penny battery. This time I don't feel like sanding the pennies, so I'm adding these zinc washers I got from the hardware store for about 3 cents each. I need around 1.5 volts, so I'll use 3 pennies, 3 washers, and 3 pieces of cardboard soaked in vinegar. This time I've rounded the cardboard edges so they won't be a problem, and I'll stack them with the washer on the bottom, the cardboard in the middle, and the penny on the top. This is one cell, and I need 3, so I'll stack up 2 more. The penny on the top is the positive side, and the zinc washer on the bottom is the negative. I'm getting just over 2 volts and 700 microamps, so I'll add wires to the terminals and use some more electrical tape to hold it together. Time to test it on the calculator. I'll press the on button, and it's incredible, the calculator fires right up. I'm testing out a few functions, and everything calculates correctly, so now I just need to clean these wires up a bit. I'll chip holes in the casing and hardwire my pennies into the battery leads, then tape the penny stack to the back. A penny-powered calculator? I really am impressed at how well this worked out. And still patiently waiting for this little green light to die out. Well, there's an idea that's worth a few cents. If you like this project, perhaps you'll like some of my others. Check them out at thekingofrandom.com.